Hello guys, welcome back to the channel. And first of all, this video is not a devlog video and this is going to be different. I'm still working on the next devlog and basically I'm in process of rigging the main character, and in case you missed the last devlog, it was me covering the entire process on how to model stylized low poly clothes, so be sure to check it out. Now I want to rig the character professionally so it will be easy for me to animate the character later on. So I found this add-on for Blender called Rain V2 and it looks great, so I like to try this for my project, and right now I'm still learning how to use it. Alright, in this video we are going to do something new. I mean, it's not literally new, it is new in this channel, and we are going to do something called competitive programming. Now what is it actually? Competitive programming is basically you given a problem set and then you need to solve it as fast as you can within a period of time, and you need to solve it by writing codes, of course. Now the important question is it fun? Well, no. But is it worth it? Well, probably, because this thing is commonly questioned when you apply to a certain technology company, and this task is called coding interview or programming interview. But we are not going to do the real competitive programming because we will not constrain ourselves with time limits. We are just going to do it for fun. Now this thing is not easy in my opinion. It requires a certain level of intelligence to solve the problem. Since I am an average, I'm going to start with easy problems, of course. And I'm going to call this type of video of mine a programming practice. And yeah, anyway, let's start to solve some easy problems. Okay, here is the first problem, searching for Nessy. In July 2003, the BBC reported an extensive investigation of Loch Ness by a BBC team using 600 separate sonar beams found no trace of any sea monster. The BBC team concluded that Nessy does not exist. Now we want to repeat the experiment. Given a grid of n rows and m columns representing the loch, and find the minimum numbers of sonar beams you must put in the square such that we can control every position in the grid. Okay, so basically this X simulates the sonar beams and it can reach in this whole area, and we need to find the minimum sonar beams we need to place in order to search Nessy in this whole area. So I think it is quite straightforward that the area that can be reached from a single sonar beam is 3 by 3 or 3 square, and basically we need to divide the area of this area over here and divided it by 3 square. So let's try out.
What? Nani?
Oh, we need to be aware that the Nessy can hide at the border of the loch, so basically we need to divide the loch dimension by 3.
Hooray!
Okay, next problem, the repetitive palindrome. You are given a string S consisting of lowercase alphabets and an integer k. Make a new string T by concatenating k copies of S. Determine whether T is a palindrome, and yeah, it's basically we need to find out whether the copy of the string is a palindrome or not. So if there is one of you guys doesn't know what palindrome is, basically palindrome is
a word, numbered phrase, or other sequence of characters which reads the same backward as forward, such as madam and race car.
For example, a word level. So if you read it forward, it sounds level, while reading it backward, it still sounds level. So let's try to multiply it for, let's say, 3 times. And so as you can see, no matter how many copies, a palindrome is still a palindrome. And how we can detect a word is palindrome? Well, obviously you can tell it by reading it, but let's try a bit of computational approach. If we compare each letter from left and right, we get that each letter from those two directions are the same, and that's the basic idea. So let's try it out.
Hooray!
Alright, I guess let's call it a day, shall we? And anyway, thank you for joining me in this video. If you guys like the video, please give a like, and if you want more, consider to subscribe, and until then, see you next time.